Hi everyone, if you are learning to code or you're thinking about learning to code, then you have come to the right place. In this video, I'm going to be solving this Find the Leaves challenge, which is one of the harder coding challenges in the Pairwise curriculum. And here in this Pairwise curriculum, we have 12 different modules that teach you everything you need to know to go from no background knowledge to actually being employable as a software developer. And if you want to work on this yourself, you can get started today just by heading over to app.pairwise.tech and then starting to work on some of these challenges just like the one here. So this challenge is a little bit harder, and I want to solve it because it is one of the more challenging challenges that we have in the curriculum here. So in this challenge, we have a tree node interface set up, and this represents a tree data structure. And we want to create a function called find the leaves, which will go through a given tree data structure and find all of the leaves in that tree. So I can jump over here and take a look at what a tree data structure actually looks like. So the idea is that you have a bunch of nodes, and the nodes are connected to other nodes very much like a tree. You can imagine that this is a tree except inverted such that the root is at the top here, and then we have edges or branches going out and linking to other nodes, which then have children nodes all the way down until you reach the end of a branch and you have no subchildren, and that is what's called a leaf node. So in this challenge, we want to be going through a data structure like this and finding all of the different leaf nodes and then returning an array of those leaf nodes. So this is a rather common type of coding question to encounter, and we're going to go ahead and dive in and just start working on this function. So I can define my function find the leaves just like this, and this can be a generic function which will have a type passed into it. And that's going to accept a root node of type tree node, and we'll pass in our generic type like that. And then we're going to return an array of type t. So whatever the value is in our tree node, we're going to return an array of those values, which are going to represent the leaves in the tree. All right, and then for now, I'm going to just return an empty array here so that this will type check correctly. And what I want to do is I'm going to solve this problem with recursion. So this challenge is one of the challenges in the recursion section of TypeScript. So we're going to solve this with recursion. And recursion is a very common approach to use solving tree data structure problems like this, because the tree data structure is fundamentally a recursive data structure. If you look at our type definition here, you can see that in the definition itself, we are referencing the actual type that we have. So essentially the left subchild here can be a tree node, and what is that? Well, that is this thing that we're already talking about. So this definition is fundamentally recursive, and so it makes sense to use recursion to solve problems like this. So what we want to do is we want to define a recursive helper method that can go through our tree and find the leaf node. So we can define this here called, we'll just say this is going to be called find leaf, and this will take a node, and this is going to be a tree node of the same type. And what we want to do is we want to say if this node dot left is equal to null, and also this node dot right is equal to null, then we have found a leaf. So this is kind of one of our base conditions here, because the left and the right children can either be a tree node or null. So in the case of these nodes that have no children, their left and right fields are going to be set to be null. And so when we find a node where both the left and the right subchild are null, then we have found a leaf node. And in that case, we want to somehow track the node that we found. And so for that, we're going to create another array out here called, we can just call this leaves. So this will be an array that exists in the outer scope of this function, which can track the leaf nodes as we find them. So here, once we found a leaf node, we want to just say leaves.push node.value. And we can even add a type annotation here and say this is of type t. And we also want to then return that array down here at the bottom. So this is our kind of base leaf condition. And then if otherwise, we want to say if the node.left is not equal to null, so if there is a left subchild, then we want to call find leaf on the left node. And the same is true for the right subchild, like this. So we want to say for the left and the right subchildren, if they exist, then just call this function again, passing in the left and the right subchild. All right, and then the last thing for us to do is we have to actually call this recursive helper method. So we need to come down here and we want to call find leaf, and we want to pass in the root node of our tree, which we get in the body or the argument list of this function, find the leaves. So we can pass that in down here, root node. And so what this code will do is it will call our helper method with the root node, and that's going to walk through the tree and find all of the leaf nodes, push their values into this leaves array, and then recursively recurse on this find leaf method for all of the left and right subchildren. So we can go ahead and run this code, and we'll see that it passes the tests. All right, so that is how we can solve this challenge, and this is a more difficult coding challenge here. We have a few more advanced concepts such as recursion and also treed data structures, which are rather tricky to work with when you're first starting out. But if you liked this video and you thought this was interesting, please hit the like button and subscribe to the channel to see more content like this in the future. And of course, head over to Pairwise if you are interested in learning to code. We have a ton of challenges here, well over 500 challenges, just like this one, which you can use to learn how to code and become a software developer. All right, thanks for watching, and I will see you in the next video.